Welcome to this class. Today we are going to discuss how can we get an estimate of the cost of a landfill. So as I was discussing with some of you, if you have to make a 1000 square feet house for yourself and assume that the land is free, 1000 square feet is a single bedroom house, 2 bedroom house or a 3 bedroom house? Yeah, I think even 3 bedrooms in 1100 square feet is made. DDA, the Delhi Development Authority gives you a 3 bedroom flat, 1100 square feet, very nice. You don't think so? Oh, well, carpet area, super area, net area, let's assume that if I want to make a house of 1200 square feet, do you know how much it will cost today? A rough idea? Means you're going to buy a house. How much money should you have in your pocket to buy a 1200 square feet flat or a house, excluding the cost of land? So as our friend was telling us that in the CPWD manual, the unit rate would be approximately 1200 to 1500 rupees per square feet, and therefore if I'm having a 1000 square feet flat at 1500 rupees per square feet, it will become 1500,000 or it will become 15 lakhs of rupees. I'll need 15 lakhs of rupees in my pocket to go buy a house for myself or a flat for myself. The question is, do we know how much a landfill costs? Just like I know per square feet it costs so much to build a house, I should know per square feet it costs so much to build a landfill. Now the issue is that in landfill the heights can vary a lot. You can have a landfill which is 7 meters high, you can have a landfill which is 15 meters high, you can have a landfill which is 30 meters high. So quite clearly, unlike in a residential area where we are talking of one level of living and therefore the height of the floor space is 3.5 meters, here you will have different costs. So what I am going to do today with you is try and estimate how much do landfills cost if they are about 15 meters high. And I am not going to focus on the total cost of landfills, I am going to focus on the cost of liners and covers and the other geotechnical components of landfills. So intuitively, okay, now let's try and focus on this. Suppose I have a landfill which is 100 meters by 100 meters in area, okay, or 1000 meters by 1000 meters in area. 100 meters by 100 meters, football field. 1000 meters by 1000 meters, 100 football fields, 10 football fields like this, 10 football fields like this, 100. So the question that we are asking is, how much would this cost? Do we have, just like we just now said, 1500 rupees per square feet, do we have a thumb rule? How many hundreds rupees per square yard or per square meter? That's what we would like to look at. What do you think is the bulk of the cost of a landfill? In a house, what is contributing to the cost of the house? Cost of the construction materials. So it is the cost of the RCC, that means the concrete and the reinforcement and the bricks. Basically, bulk of the cost is the cost of the materials plus the additional cost of construction, which is the cost of labor and the skilled manpower. What do you think constitutes the cost of a landfill? The cost of the liner, the cost of the cover, and there may be a placement cost of the waste inside it. So that would cost with the cost of a landfill. Additional cost will be the road that I have to make, the small buildings that I have to make, right? The appurtenant works, the drainage channels. So we are going to look at a landfill where we are not going to take into account the other costs. Somebody wants to put a composting plant, that may be a separate huge cost. Somebody wants to put a waste to energy plant, that may be a separate. If the entire land that we have is going to be made of a landfill with waste dumped on it, and the appurtenant infrastructure is nominal, what is the cost? That's what we look at. And intuitively, one feels that maybe the cost of the liner and the cover is the dominant factor, right? So, as we said, the focus today is on the cost of geotechnical components of landfills, which are the liners and covers. I'm not going to focus on the cost of pipes and of the pumps and of the sumps, because those will be also additional costs. But just like in a house, the cost is basically of the concrete and the reinforcements and the bricks. It's not about the plumbing. In that 1500 rupees per square foot that we are talking of, we are not talking of the most expensive fittings of taps which cost the roof, like a 5-star hotel. We are also not talking of the cost of tiles and glossy finishes which cost a lot. We are talking of the basic costs. So that's what we are going to look at here. So first, I'd like to look at a landfill study, and this landfill study for the year 2003. It is for an above ground landfill. Water table was 20 meters below the ground surface. Operating life was 16 years. Post closure care period 25 years. Two types of waste: hazardous waste. Then the size of the landfill is 200 meters by 220 meters by 220 meters, okay, square. And municipal solid waste 800 meters by 800 meters. So first, let's look at the municipal solid waste landfill. 1000 tons per day of waste coming in. Total height of the landfill was 15 meters, out of which the liner plus cover would take 2.7 meters. And the balance 12.3 would be taken by the waste and daily cover. And as a thumb rule, your daily cover may be 10% of the waste. So remember that the total height of the landfill is 15 meters, 2.7 has gone into the liner and cover. That's why people keep on wanting to make the liners and cover thinner and thinner. If you put a geosynthetic clay liner instead of clay, you will get a meter or 90 centimeters. If you put a geocomposite drain instead of sand, you will get 30 centimeters more. So everybody wants to make this thinner and thinner. But we are going to look at this case, and if 700 tons per day comes in onto the same area, the height is about 11 meters, and if 1300 comes in, it's about 20 meters. So here the base area is 800 meters by 800 meters, whereas here the base area is 220 meters by 220 meters. Here it's tons per annum. Please see, this is TPA and this is TPD. The amount of hazardous waste which comes out is normally much smaller than the amount of municipal solid waste which comes out in any urban area. So here we are talking of a hazardous waste landfill. The height of liner and cover has gone up from 2.7 meters to 3.6 meters. You can go and look back at the components. And here the base case is 25,000 tons per annum. 15 meter will be the height, 11.4 meters for the waste and daily cover, and 3.6 for the liner and cover. We are going to look at liner costs, cover costs, landfill costs, and influence of the height of landfill. Let's just recall, this is our liner for a municipal solid waste landfill. Thickness is 0.3 plus 0.9, 1.2 plus other elements. If you look at it very closely, it is going to have many more components: a separator filter, the leachate collection layer, a protector, the geomembrane, the clay, and a separator filter. So many layers. If I look at the hazardous waste landfill, this becomes even more thicker. This is 1.8, 0.3 here, 1.5, 1.8 meters just at the bottom. If it's a double composite liner, there are even more elements. Similarly, if you look at the cover, in the municipal solid waste landfill, 45 cm, 0.45 and 0.15 and 0.6 and 0.3. So this whole total becomes 1.5 meters, right? 1.5 at the top, 1.2 at the bottom makes it 2.7 meters, which you saw in the table that I had shown you. If you have a hazardous waste landfill, 0.6 and 0.3, 0.9, 0.6 and 0.3, 0.9, that becomes 1.8 meters at the top for the cover. So out of the 15 meters, 1.8 meters is being taken by the cover, and similarly 1.8 meters is being taken by the single composite liner. And again, in the cover you have many interfaces, and if you are trying to recover methane gas as well, then you have to put a geomembrane. So this becomes the cover for municipal solid waste landfill also and hazardous waste. But remember, in municipal solid waste landfill, the thickness of the elements is different from the hazardous waste landfill. So to estimate the cost, you need to know the cost of materials. So in 2003, when this exercise was done, the cost of placing, spreading and compacting the waste was rupees 50 per cubic meter. It's like a huge earthwork problem. You understand this? Earthworks, you want to make an embankment, how do you pay the contractor? You have to construct a road embankment from here to Meerut, 5 meters high. How will you work out the cost of the project? Fundamentally, it will be the cost of earthwork. You will find out the volume of the earth, multiply it by the unit rate at which the earth is available, at which it can be transported, at which it can be placed with compaction. And you multiply and you will get a value. Same thing here. The waste is being, once the waste arrives, which is brought to the site, you place it, you spread it and you compact it, and the cost of it is 50 rupees per cubic meter. If you have local soil which you are going to use as the topsoil, the rate is 120. This is 2003, please note, how many years ago? 14 years ago. So these were the rates at that time. Medium fine Yamuna sand 200 rupees per cubic meter, Badapur sand 400 rupees per cubic meter, this is coarse sand, gravel 550 rupees per cubic meters, clay from 200 kilometers 600 rupees per cubic meter, amended soil, Delhi silt plus 5% bentonite 250 rupees per cubic meters. Then all these are in cubic meters because this is earthwork, and everything here is in square meters because these are planar geotextiles which come from a factory. 1.5 mm HDPE geomembrane 250 rupees per square meter. So I am giving you an idea of what they cost you in 2003. I will also give you the values today. Just before coming to this class, instead of looking at a CPWD manual, because they may not have everything regarding geomembranes and geotextiles and their unit rate, I rang up a civil contractor friend of mine and I said, look, I am going to give this lecture today, I need the latest rates on this and I will look at it a little later. But let's see what this study threw up. Now, you want to do the costing of a liner system, you know the thickness, you know the areas, you work out the volume of material required. So if I look at the liner system, I would have a leachate collection layer, I would have a geomembrane, I would have a compacted clay layer, then I would have a filter between the waste and the leachate collection layer, a protector between the leachate collection layer and the geomembrane, and some pipes and sumps and pumps. So these are the quantities multiplied by the unit rates for the municipal solid waste landfill, and these are the quantities multiplied by the unit rates for the hazardous waste landfill. This is 800 by 800 meters square. The amount of waste which is coming in is much larger. This is 220 into 220 meters square. So you get some figure at the end which you can convert into the cost per square meter. Just like we have the cost of construction per square foot, and the figure which comes out for a liner system here in 2003, when the landfill height of 15 meters was 800 rupees. 800 rupees for municipal solid waste per square meter and 900 rupees for hazardous waste. But this is single composite liner. If you go to a double composite liner, it became about 1300 rupees per square meter, separately listed here. So remember, the geomembrane and the leachate collection layer and the compacted clay layer are the main components of this cost. Let's now look at the cover costs. Now we have become experts. Topsoil, then drainage layer, then geomembrane, then compacted clay. Here in the municipal solid waste you don't have this geomembrane. Gas collection layer, separators between this layer and that layer and this layer and that layer. Similarly to what we did, and this cost comes 590 for municipal solid waste and 1000 for hazardous waste. Is this more than the cover or less than the liner or less than the liner? You remember what was the cost for the liner? About 800, and this is about 600, and the reason is there is no geomembrane in it. Should I put a geomembrane in it? What will happen? The cost of geomembrane I have shown you, I think, is 250 rupees per square meter. 250 will get added onto it. So the cover is no cheaper than the liner. First, please remember that, especially if you are trying to extract methane gas. Look at the hazardous waste landfill. What is the cost here? And what is the cost of the single composite liner? 990. So it's the same cost. Similar costs. Similar costs are emerging. Then let's look at the total landfill costs and see what is the contribution of the cover and the liner to it. There's the site acquisition costs. So I told you, don't take land costs into account. Mostly for these projects, the government will give these at nominal value because either they'll be self-operating the landfills, the municipalities. Even if they give it to an operator, you can't sell it at a commercial value. It's your waste and my waste. If you give it to an operator, you will charge him for the land, he will charge us back at the tipping fee point. So some site development costs, site assessment, site development, roads and everything, then liner and leachate collection, operation, waste placement and final cover. Just see the figures here, both on the municipal solid waste landfill side and the hazardous waste landfill side. These are gross figures, not per square meter, which we did earlier. We'll convert the whole thing into square meter. So there is some site development cost, but the liner and leachate collection is higher. Waste placement, this is for 15 meters high. So this is the cost of placing 15 meter high waste at 50 rupees per cubic meter. Okay? And this is the cover. So do see that the liner and the cover have a significant role to play in the cost of a landfill. What is this percentage cost of the total? This table will continue forward. Let me finish this. There will be cost for post-closure care, and then there will be contingencies, emergency, operator's profit, all that. So in a sense, you get a value of the costs, and you can see which component contributes how much to the total cost. And I'm going to go back and show you that the final cover and the liner cost contribute about 40 to 50% of the total cost of a landfill. It's like saying in your house, the floor slab and the roof slab contribute to more than 50% of the total cost. Everything else belongs to the walls and the plumbing and the electricity ducts and everything else. So more than 50%, 40 to 50% of the cost in this study accrues to liners and covers. However, if I increase the height of the waste, instead of a 15 meter high landfill, on the same plot, if I was to make a 30 meter high landfill, what will happen? Yeah, the cost of the waste will go up. This 195 will become 400 now. It will become double because you double the height. Then the contribution of the liner and the cover will go down. So an important thing is height of the landfill plays a significant role as far as the percentage contribution to the cost of landfilling is concerned. You make a very thin landfill, you make a 7 meter high landfill. Okay? How much is going to go into the liner and the cover? 2.7 and 3.6. Further 10% is going to go into the cost of daily cover. So kya bacha? Very little waste is placed. So if you want to have a low impact of the cost of liner and cover, don't make low height landfills, make high landfills, because neither is the liner going to become thicker nor is the cover going to become thicker if you go higher. Are you understanding what I am saying? Therefore, the percentage contribution of the liner and cover go down. It is like if you have a cost of land, you want to share it amongst more people, please make your building higher, and the cost of land will become shared by more people. Also, per square meter, I think it's not shown here, but the hazardous waste landfill is costing us 2000 lakhs. And what was the area of this landfill? Yeah, 220 by 220. So you can figure out what is the cost per unit area. Can somebody do this quickly for me? 2029 into 10 to the power of 5 divided by 220 into 220. Or somebody can do it approximately for me. 2000 into 10 to the power of 5 divided by 200 into 200. So 5,000 rupees per square meter is the cost of your landfill if it is 15 meters high. Just check for the municipal solid waste, how much does it work out? 17957 divided by 800 into 800. I don't know, somebody will have to check it out for me. It will be cheaper. So one is 5,000, one is 3,000. So that's the cost in 2003. So let's see whether we can now do what it costs today. But before we do that, I just want to bring you this picture. So the important thing for you to note is if I divide it by the weight of the waste inside the landfill, then the cost of landfilling is 500 rupees per ton here for hazardous waste, single composite liner, and it's about 300 rupees per ton here for municipal solid waste, right? So you can understand what is the cost of landfilling per ton of waste, right? Now, I had taken municipal solid waste 1000 tons per day, 15 meter high, and my value is 309. If I make the landfill height 20 meters, then the cost of disposal is 250 rupees per ton. But if I make it of lower height, the cost goes up. So what we are trying to say is that as the height of the landfill changes, the cost of disposal per ton goes down because the contribution of the liner and the cover goes down, right? But do remember that your landfills are going to cost between 3,000 to 5,000 rupees per square meter at 2003 values. Agreed? Similarly, here you will find the same thing. For 15 meter high single composite liner, the landfill was 500 rupees per ton, and for double composite liner, it is 555 per ton. Do not treat these as absolute values. Different cities will have different costs of materials. If topsoil is 120 here, it may be 200 somewhere else. If sand is 300 here, it may be 700 somewhere else. So this is not across the country. Now let's do a simple method for estimate of cost of liner and cover. Cost of liner and cover, if we recall correctly, was for hazardous waste landfill was almost 1,900, 1,000. So both landfill cover plus landfill liner for the hazardous waste together would be 2,000 rupees per square meter, and the total cost was 5,000 rupees per square meter, showing that about 40% of the contribution of the landfill is from liners and covers. Now let's come to today, right? And let's try and see, can we do this simply? And all I'm going to say is, if this is your landfill And I've often told you landfills are like this. Okay, we make them in various strange ways in various books, but more or less landfills are thin and broad. So let's take 1 square meter, right? When I look at 1 square meter, I'm going to have a cover, then I'm going to have the waste, and then I'm going to have the liner. Agreed? So all that I've got to do, if I give you the unit rates, if you know the thicknesses, and if you know the rate per square meter of a geosynthetic, you can compute the cost of this, the cost of placing this, and the cost of placing this. And if you add this, this should be about 50% of the total cost. That's what we've done. But we would get an idea as to what is the current cost per square meter. Agreed? So let's look at this simple method. First, let's look at what's happened to costs. In our first 2003 example, there was no computation of what? Of how much does it cost to make grass grow at the top? Because all landfills must have a green top. Now we have a handle on it, having done 4 or 5 landfills across the country over the last 5, 10 years. Today, if you want to get an outside contractor to plant grass at your landfill and establish it in 3 months, he charges you rupees 80 per square meter. Right? Local topsoil is typically not available, but if it is getting excavated somewhere and you want to use it, it may be available to you at 200 rupees per cubic meter. Otherwise, you'll have to dig up your own soil from the landfill if you want to use the local topsoil. Right? Medium to fine sand in Delhi is now available at 500 rupees per cubic meter. Coarse sand and gravel is available at 1500 rupees per cubic meter. Clay from 300 kilometers is available at 2000 rupees per cubic meter. The HDP liner today is 350 per square meter, and the non-woven geotextile 200 GSM is rupees 100 per square meter and 400 GSM is 200 per square meter. We are going to use the thicker geotextiles in the bottom liner area because the overburden stress is very large. And we can use the lighter ones at the top, though I don't agree with it, but still people are using the lighter ones. Additional data which we are seeing, to leachate treatment costs about 5 rupees per liter, and waste placement and compaction now costs about 100 rupees per cubic meter. With this data, let's design this. Okay? So, I want you to recall the cover is 0.45, the drainage layer is 0.15, the compacted clear liner is 0.6, and the gas collection layer is 0.3. Leachate collection is 0.3, geomembrane is 1.5, compacted clay liner is 0.9, and we will have the various interfaces. And I am going to use this example, except that also introduce a geomembrane because I want to recover the gas. If I don't want to recover the gas, then I don't need a geomembrane, but if I want to recover the gas, I'll put a geomembrane here. And therefore, these are your interfaces. Cover. Okay? So let's just quickly tell me what are the elements. If I come down the cover, I need to put the cost of vegetation followed by, pardon? No, there is in between, oh, there's vegetation, topsoil. Then I have a separator filter, which will be a GTX for me. Then sand drainage layer. I'll put a drainage layer. You'll have to decide what you want to use. Then, then protector. That's again a GTX. Then geomembrane. Then compacted clay liner. Then separator filter, then gas collection layer, and then the waste. Okay? Now 1 square meter in plan, I want you to fill this costs for me here. You need the unit rates, I'll bring the unit rate slide back. Do you understand what has to be done? Yes or no? You take a square meter of plan area and tell me the cost of all the elements per square, because you want in the end the cost of the cover and cost of the liner per square meter, right? So the first one will be 80, because that value is given per square meter, it's not per cubic meter. So that will be the cost of developing 1 square meter of grass. What about the local topsoil? How thick is the local topsoil? 0.45. If you don't remember, I'll show you again. It's 0.45. If it is 0.45 and the rate is 200, how much will be the cost? 90. क्या divide करोगे? Cost is per cubic meter. Your plan area is 1 square meter. Your depth is 0.45 meter. So the amount of material required is 0.45 cubic meter. 200 rupees into 0.45 will give you 90 rupees. Okay. You will not use medium fine sand, please. You will at all the places be using the coarse sand gravel. So again, to remember that the drainage layer is 15. In between you will have the geotextile. Does everybody have this? 200 into 0.45, 100 GSM, 0.15 into 1500, 100 GSM, 350, 2000 into 0.6, 100.3 into 1500. So the total cost of the cover per square meter is now almost 2,700. What was it in 2003? We had done it in the slide earlier. It was much lower than this. We'll go back and show it to you. This is the cost of the liner system. For the municipal solid waste landfill, the cost of cover per square meter was 600 rupees. And now it is, as per the rates which I have given you, 2695. Similarly, I can do the calculations for the liner. Similarly, I can do the calculations for the liner, and for the municipal solid waste landfill, the liner cost is about 3,200. So if I now add the liner cost to the cover cost, how much does it become? 2,700 plus 3,200 is how much? Yeah, so it's about 6,000 rupees per square meter for the liner and cover. How much does it cost for you to make a house? 6,000 rupees per square meter, approximately 600 rupees per square feet, right? From this we can observe that the cost per ton works out to be 491 per ton. This is evident from the computations in the first 3 lines. If we double the height, this cost falls to 245.5 per ton. So all that we are trying to say is it's about today 6,000 rupees per square meter for a liner and a cover, and if these are 40 to 50%, the total cost of a landfill becomes 12,000 rupees, and the cost of municipal solid waste disposal as per the rates and as per the size that we have done is about 491. If instead of putting 15 meter high, I had put a 30 meter high landfill, which we don't do because of visual reasons, then the cost would have been lower, because in the same area I would be accommodating much more waste. So the cost is high because what is the one which is contributing the maximum in terms of cost here? Please note, In this 2695, 1200 comes from the clay. In this 3200, 1800 rupees comes from the clay. Can I reduce it? The clay is very expensive because I am bringing it from 300 kilometers. What will happen if I replace the compacted clay liner by local soil plus 10% bentonite? What's the cost of local soil? 200 rupees. What's the cost of clay? 2000 rupees. What is the cost of local soil plus 10% bentonite? Bentonite in the market comes in bags like cement. It is used as a drilling fluid and it costs approximately the same as cement. A bag of cement which is about 50 kilograms will cost you about 300 or 350 rupees. You can Google it up, find the value of cement in Delhi to the nearest 50 and use that computation. What is the effect of replacing the compacted clay liner by local soil and 10% bentonite, right? And that cost will be much lower because the 2000 will be replaced by a much lower value. The total cost of liner and cover per square meter and per ton if I had a double lined hazardous waste landfill. We have solved this example for a municipal solid waste landfill, but if I had a double lined hazardous waste landfill, what will be the cost? Have a good day.